Okay, I thought we'd do a little matrix multiplication today. One thing you have to look at is this. When you multiply matrices, if you have a matrix that's m by n, and your second matrix is n times p, these matrices can be multiplied. Columns here, rows here have to be the same. Have to be the same. The other thing I want to tell you is this, is that matrix A times matrix B is not equal to matrix B times matrix A. They do not share a commutative property. And at the end of this video, I'll talk about the properties they do share, but they don't share a commutative property. So order matters here. Order does matter. Isn't that weird? It's absolutely bizarre. Anyway, let's try to do this piece of work right here. It's not too difficult. You just have to memorize the order in which you're supposed to work. And the first thing we're supposed to do is this. We're supposed to multiply the first row by the first column. So here's the first row. And here is the first column. So we're going to do 3 times 1 plus 2 times 2. And this is, we're working on our answer here, so we're creating a matrix. And then from there, what we're going to do to get the next piece down is we're going to take the second row. Let me see if I can pick this up. The second row times the first column. The second row. Does that work pretty good? That's actually pretty cool. So we're going to multiply negative 1 times 1 plus 0 times 2. 0 times 2. And now any idea what we're going to do next? Right, we're going to do the first row, right? So first row times, whoops, wow, that's not too cool, by second column. By second, all right, and that, wouldn't that look like this? That would look like 3 times negative 4 plus 2 times 1. Now we're going to do the same thing here, except we're going to do second row by second column. And second row by second column would look like this, wouldn't it? It would look like negative 1 times negative 4 plus 0 times 1. And what we would finally get as our answer here, when we did all this math, here is we would get 7, negative 1, negative 10, 4. And this is called our resultant matrix. Our resultant matrix. So I wanted to show you that. I'm going to do more of them. The next thing I'm going to do, frankly, is I'm going to go and show you how to do this on your CAS. You should know how to do it both ways. And the only way to really learn how to do this is to practice it a ton of times. So I hope that's what you're doing, isn't it? Let's take a look here. Oh, the rules. Really quick, really quick, if you don't mind. This is what we know is true. I talked about the first one. There is an associative property of matrices. So if you take matrix A times matrix B times C, it is equal to, if you multiply A times B first and C last. But look here, the order doesn't change. When the order changes, it gets a little bit weird. We have a left side distributive. Distributive property, which says that if we take A times B plus C, where A is a matrix, B is a matrix, and C are matrices, you will get matrix AB plus matrix AC. And the same thing is true if you do a right side, because we're saying order matters sometimes. In this case, it doesn't. We have a right side rule of distributability, which says that if we have A plus B times quantity C, it is the same as AC plus BC, are the resultant matrices. And then we can also talk about a scalar. Remember, a scalar is just a number. So if you have a number like 5, we have associative property of a scalar. And I'll show you a scalar really quickly. Just give me a second. So our scalar is C. We want to multiply it by matrix AB, it is the same as C, little c. C is a constant AB, which is the same as C, which is the same as A times little c B. Look, all I'm saying about a scalar is this. Let's say we have this, 5 is our scalar, 5. Look, we have this y, 3, and 2. All we're going to do is distribute this thing here, 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 and here. Remember, this was a y, so we get 5x plus 5y plus 15 and 10 here, and this is our resultant matrix. So that's how we'd use a scalar. All right, I hope this was really helpful. Matrices are incredibly powerful. I'll go into how the military uses them and how industry uses them and how you can actually use them to figure out stuff that nobody else can figure out. So matrices are actually awesome. So stay with me, and I'm going to go on and do the next one on how to do this using your calculator. If you haven't already subscribed, please do, and your comments are always welcome.